Hey guys, welcome to question FM317 of the Further Maths Fortify study guide. This question reads, a scaling triangle ABC is presented below. A smaller similar triangle is inside ABC. So we've got a similar triangle in there, and this overall diagram should be similar to the one that you have in your books. The question then goes on to ask the angle theta in degrees is closest to what? And then we're given 5 different options here. So something that we should start looking at here is how we might start figuring out what this angle here is. So looking around, we notice that in terms of the cosine rule, we can't really do much because our angle is not an included angle. So 56 is an included angle because we've got both these side lengths, but we don't have this side length AB. So this angle here is not included. And when we start looking to see if we can use the sine rule to help us answer this question, given that we haven't been told that this is whether this is a right angle triangle or not, so we can't really rely on trigonometry, we're going to be using the cosine or the sine rule. You'll also notice that with the sine rule, we don't have a way of directly relating angle A inside A to angle C inside C or angle B inside B. So we're going to need to create, we're either going to need to find the side C length, the length of side C, or we're going to need to find the angle of B. Now, it's pretty hard to find the angle of B from here. However, we can pretty easily find this side length C using our cosine rule. So, using a slightly rearranged cosine rule, because our cosine rules are made so that our unknown side is A, so we're going to do a little bit of rearranging, and we're also going to make it straight, a formula where C is the subject as opposed to C squared being the subject of the formula. So a slightly revised formula would be C equals the square root of A squared plus B squared minus 2AB times cos of angle C. So whacking in our known variables, we should get that this is equal to 3.6 squared plus 9.4 squared minus 2 times 3.6 times 9.4 times cos of 56 degrees. Whacking this all into a calculator, you should get an answer that's roughly 7.967 centimeters. Now I'd advise keeping that exact unit for later use, but it doesn't hurt to take these 3 decimal places and solve it this way. So now we've actually found a length for up here, which means that we can relate angle C to side C and angle A to side A. So we can now go on to use the sine rule to help us figure out what this angle alpha is. So the sine rule that we're going to use here is sine of C over C should be equal to sine of A over A. Substituting our known values in here, we should get sine of 56 degrees over 7.967, or here's where you can copy and paste your answer from earlier into there in your calculator. We should get is equal to sine of alpha over 3.6. Now here I would recommend using solve and solving for alpha, so you don't have to put an alpha symbol in your calculator. This could be sine of x and you could be solving for x. However, once you solve for this value, you should get an angle that is fairly close to 22 degrees, which of course ends up being option B. If you guys have any questions about this question for us, please leave them in the comments below. Otherwise, I will see you in the next video.